So remember when we were talking yesterday about section 3.4, talking about the rational zero theorem, basically what that allows us to do is that allows us to generate a list of possibilities in terms of what the rational zeros of a particular polynomial might be. So, list all possible rational zeros of f of x equals negative x to the fourth plus 3x squared plus 4. This isn't asking you to actually find which ones are these zeros. It's just asking you to generate a list of possibilities that you could check. So if you recall, at the end of the lesson yesterday, we talked about P over Q. P, those are the factors of the constant. Q are the factors of the leading coefficient. What are the factors of the constant? Right, 1, 2, and 4, right? Those are all the factors of the constant. And technically speaking, they could be positive or negative. So when I make this list, I can do plus or minus 1, plus or minus 2, or plus or minus 4, because the constant's 4, those are all the things that divide into 4. What about the leading coefficient? What is the leading coefficient? It's negative 1. So what are the factors of negative 1? Right. If there's just a 1 down here, then the list is pretty much just what's up in the numerator. So that means that if this particular function has rational zeros, they're either going to be plus or minus 1, plus or minus 2, or plus or minus 4. So instead of having infinitely many numbers to pick from to try to see if they are, a 0, I've used this theorem to narrow the list down to 6 possibilities. That's huge. That's like whoa dang important. Let's do the same thing, but with a different function here. G of x equals 15x cubed plus 14x squared minus 3x minus 2. So once again, generate my list of possibilities. P over Q. So, what will we have for P? Factors of the constant. So what about Q? All right, that's one of them. I like to go in order from smallest to biggest. So yeah, you'd have plus or minus 1, because 1 goes into 15. You'd have 3, 5, and 15. 7 does not go into 15. Now, I have to be able to generate a list from here. In my opinion, this is the easiest way to do it. So you choose one of the numbers from the denominator, and then you run through the numerator. So if I pick 1 in the denominator, I'd have plus or minus 1 and plus or minus 2, because those would all be divided by 1, right? Then I go to 3. So I'd have plus or minus 1/3 and plus or minus 2/3. Because now I have a 3 on the bottom. Finish the list. What comes next? Yeah. Plus or minus 1/5, plus or minus 2/5. While that's a lengthy list, it's still a lot smaller than an infinitely long list. Now, let's take this a step further. We can generate this list, but let's actually put it to good use. So find all zeros of f of x equals x cubed plus 2x squared minus 5x minus 6. Well, the first thing we would do is we would generate the list of possibilities. So what do we have? It's always nice when the leading coefficient is 1, that way you don't have to mess with any fractions. It's a beautiful thing. All right. So basically that top part is my list. I've got 8 things on it. So if I want to find all the zeros, how might I proceed? Yeah, synthetic division, and I'm just going to start trying different pieces of that list out. What number would you like to try first?
-1.
Okay. So let's see. And honestly, this part is just trial and error. Okay? You just pick something, try it, see if it works. But you pick something off the list, obviously. So, how do I know if it worked or not? Yeah, it divides evenly. In other words, the remainder is 0, right? So that means that it might help if I kept track of what the zeros are. So x equals -1 is one of the zeros. Now, I could keep going. I could keep trying these with synthetic division. But if you notice, what does this mean right here? Plus x minus 6. That's quadratic. I ought to be able to factor that, right? Or at the very least, I ought to be able to use the quadratic formula on it. So what does that factor into? So what should I add to my list of zeros? There you go. And honestly, at this point, if you're listing the zeros, I wouldn't crucify you if you didn't put x equals. If you just put zeros and then listed the numbers, I would let that go. Fair enough? Because if we're looking at zeros, we're looking at values of x. Everybody knows that. All right. So, let's try another one. Where do we start? P over Q. Somebody else give me what P might be? And Q? Right. There are only 4 possibilities here. And basically, this is just trial and error. So, what would you like to pick? 1. What does that mean? Yeah. So it wasn't 1. 1 didn't work. So, pick a different number. -1 sounds good to me. What was it? 1, 7, 11, and -3. Well, that didn't work either. So it wasn't -1. 3 times the charm, maybe? What do you want to pick?
If there's only like 4 possibilities, there's 3 solutions. I've already tried 2. And there's only 2.
I like the thought. Watch and learn. You guys want to try -3? Okay. All right. Oh, there we go. That's one of them. Now again, you can continue this process, but look at what we have. That'll be quadratic, right? This is x squared plus 4x minus 1. I'll let you think about what we might do to figure that out while this video is rendering.